if log x to the base 2, positive log x to the base 4, positive log x to the base 16 is equal to 7 over 2, then find the value of x. So we have to solve for x in this equation. That is, we have to find the value of x. Okay, let me rewrite the given equation. That is log x to the base 2, positive log x to the base 4, positive log x to the base 16 is equal to 7 over 2. Here in front of each logarithm, we don't find any number. Okay, in front of a logarithm, if there is no any number, we have to understand that the coefficient of logarithm is 1. That is, there is 1 in front of each logarithm. 1 is multiplied. Okay, now what I'm going to do is, I'm going to move this log x to the base 2 to the denominator. Whenever I move a logarithm from numerator to denominator or denominator to numerator, I have to switch the argument and base of the logarithm. So the next step, it will be 1 over log 2 to the base x. So the same thing I do with the second logarithm. I get 1 over log 4 to the base x. The third one, I get 1 over log 16 to the base x is equal to 7 over 2. Here 2, 4, 16, all of them are powers of 2. So I write the first fraction as it is. The second fraction, I write log it to the base x. I can write this 4 as 2 square. And in the third logarithm, I can write this 16 as 2 to the 4th power is equal to 7 over 2. Here, in this logarithm and in this one, I can use a power rule of logarithm. That is, this exponent can be moved in front of the logarithm over here. The same thing I can do here. So the resulting equation will be 1 over log 2 to the base x positive 1 over 2 times log 2 to the base x positive 1 over 4 times log 2 to the base x is equal to 7 over 2. Okay, here, if I want to add 2 or more fractions, I must get the same denominator. So here I have log 2 to the base x, log 2 to the base x, log 2 to the base x. But here I have 2 and 4. The least common multiple of 2 and 4 is just 4. So to get the same denominator, I multiply the first fraction, numerator and denominator, the first fraction by 4 and the second fraction by 2. When I do so, I'm getting 4 over 4 log 2 to the base x. The second fraction, I get 2 over 4 log 2 to the base x. Then the third fraction should be written as it is 1 over 4 log 2 to the base x is equal to 7 over 2. Okay, I get the same denominator for all the 3 fractions over here. So I can take the denominator once and add the numerators. I get 4 positive 2 positive 1 over 4 times log 2 to the base x is equal to 7 over 2. The resulting equation is 7 over 4 times log 2 to the base x is equal to 7 over 2. To get rid of this 7 and 4, I multiply both sides of the equation by 4 over 7. So 4 will cancel out and 7 will cancel out here. On the right side, 7 and 7 will cancel out. 2 goes into 1 times, 2 goes into 4 twice. So I get 1 over log 2 to the base x is equal to 2. Okay, I'm going to move this logarithm to numerator. As I told you already, if I move a logarithm from numerator to denominator or denominator to numerator, I have to switch this argument and base. Then we'll have log x to the base 2 is equal to 2. So here, the argument 2 has become the base and the base x becomes the argument because the logarithm is moved from denominator to numerator. Okay, now this equation is in logarithmic form. So to solve for x, I'm going to convert this equation to exponential form. For that, I have to move this log to the base 2 to the other side of the equation. When I move this log to the base 2 to the other side of the equation, I have to ignore this logarithm. I just consider only this base 2 on the other side, and the value which already exists on the other side will become the exponent of this base. So I get x is equal to, so this 2 will be base here on the right side. The 2 which already exists on the other side will become the exponent. So I have to ignore this logarithm. When this log to the base 2 is moved to the other side, ignore the logarithm. So now x is equal to 2 square is 4. We have solved for x. The value of x is 4.